Alright, so now we're going to look real quickly at what we call the alternative form of the derivative. We're not really going to use or see this that much in this class, but it is important to understand. It is something we will see a little bit and we will use a little bit. So you do need to know it, but it's a different way to find the derivative. And we actually, again, just like the difference quotient, we've seen this before. We saw this first semester. So we want to understand how and when to use the alternative form of the derivative. What is that? Great, good question. So the alternative form of the derivative, f prime of c, is the limit as x goes to c of f of x minus f of c over x minus c. Again, notice that is just a different way to write slope. y2 minus y1 over x2 minus x1. The big thing we want to notice on this, though, is notice we're doing the limit as x goes to c, and notice this is finding f prime of c. It is not finding f prime of x. Okay, so the function is f of x, but this is going right to finding the derivative at a value, where c is some value. So that's a big thing we want to make sure we understand about this alternative form. Why is the alternative form useful? Well, one reason why it's useful is because it allows us to find left-handed and right-handed limits. Whereas when we use just the regular difference quotient, we're always doing that as the delta x goes to 0, and so it doesn't allow us to, it's not as useful in finding one-sided limits, and this will be helpful in what we're going to look at later in another video, in determining if something's actually differentiable. So we need to be able to do one-sided limits, and this alternative form allows us to do that. So, alternative form, it can be a useful method for checking for differentiability. It's a tough word to say. Differentiability at a point by evaluating one-sided limits.